Example 7. Redraw the following circuit in the frequency domain and find the voltage across the resistor, inductor, and capacitor. So we are given a circuit in the time domain with a source 10 cosine 2000 T amps, a resistor 90 ohms, an inductor 32 millihenry, and a capacitor 5 microfarad. So the first thing we do is convert from the sinusoidal steady state or time domain to the frequency domain. We write the current source as 10 angle 0 degrees. We write the resistor as 90 ohms. We note that the source has a frequency of 2000 radians per second. So the impedance of the inductor is J omega L, or J times 2000 times 0.032. So the impedance of the inductor is J 64 ohms. The impedance of the capacitor is negative J over omega C, or 1 over J omega C. So that's 1 over J times 2000 times 5 micro. And so when we solve for the impedance of the capacitor, we get that the impedance of the capacitor is negative J 100 ohms. So next we're going to find VR, VL, and VC, the voltage across the resistor, the inductor, and the capacitor, and then use those to find VS, the voltage across the source, by using Kirchhoff's voltage law, that the sum of the voltages around the loop is equal to 0. So we will label VS, the voltage across the current source, positive on top, negative on the bottom. So VR is 10 angle 0 degrees times 90. That's I times R, or 900 with an angle of 0 degrees, and the units are volts. In the time domain, that would be VR of t is equal to 900 cosine 2000 T volts. VL, the voltage across the inductor, is 10 angle 0 times J 64, or 10 angle 0 times 64 with an angle of 90 degrees. So the voltage across the inductor is 640 with an angle of 90 degrees, and the units are volts. Or in the time domain, 640 cosine 2000 T plus 90 degrees. And notice here that the voltage leads the current by 90 degrees, just like we saw in the theory. The voltage across the capacitor is 10 angle 0 degrees times negative J 100, or 10 angle 0 degrees times 100 with an angle of negative 90 degrees, which is 1000 with an angle of negative 90 degrees, and the units are volts. So in the time domain, VC of t is 1000 cosine 2000 T minus 90 degrees. So using Kirchhoff's voltage law, Vs is equal to VR plus VL plus VC. So in rectangular form, that would be 969 minus J 360 volts. Using polar notation, angle notation in polar form, 969 with an angle of negative 21.8 degrees in volts, or in exponential form, 969 e to the j 0.38 volts. So in the time domain, we get that Vs of t is equal to 969 cosine 2000 t minus 21.8 degrees, and the units are volts. Example 8. Redraw the following circuit in the time domain, frequency domain, and find out of the current through the resistor, the inductor, and the capacitor. So notice that we have a voltage source which is 10 100 kT plus 20 degrees. Our first job is to rewrite that as a positive cosine so we can then convert the circuit to the phasor domain. So using our phasor diagram, if it's sine angle 20 degrees, that's the same as cosine with a delay of 70 degrees. So we will rewrite the source as 10 cosine 100 kT minus 70 degrees. So now to convert the circuit from the time domain to the frequency domain, I'm going to redraw this as a voltage source in parallel with a resistor, in parallel with an inductor, in parallel with a capacitor, where the source gets a value of 10 angle negative 70 degrees. The resistor gets a value of 10 ohms because the impedance of a resistor in the time domain or frequency domain is exactly the same. The impedance of the inductor is J omega L, where omega is 100,000 radians per second. So that becomes J 4 ohms. And the impedance of the capacitor is negative J over omega C. So negative J over 100,000 times 1 micro is negative J 10 ohms. So the current through the resistor is V over R, or 10 with an angle of negative 70 degrees divided by 10, which equals 1 with an angle of negative 70 degrees. Or in the time domain, IRT is equal to the cosine of 100,000 T minus 70 degrees in amps. The current through the inductor is V over J omega L. So that's going to be 10 with an angle of negative 70 degrees divided by J4. So that equals 2.5 with an angle of negative 160 degrees. Or in the time domain, IL of T is equal to 2.5 cosine 100,000 T minus 160 degrees. And the units are amps. So the current through the capacitor IC is equal to V divided by negative J over omega C, which is 10 angle negative 70 degrees divided by negative J10, which equals 1 with an angle of positive 20 degrees. Or if we write it in the sinusoidal steady state time domain, IC of T is equal to the cosine of 100,000 T plus 20 degrees. Now we're going to use Kirchhoff's current law in order to find the current flowing up through the source. So IS is going to equal IR plus IL plus IC. And the result is 1.8 with an angle of negative 126 degrees, and the units are amps. So we can now write IS as 1.8 with an angle of negative 126 degrees, or negative 1.05 minus J 1.46 amps, or 1.8 e to the negative J 2.199 amps, or in the sinusoidal steady state, IS of t is equal to 1.8 cosine 100,000 t minus 126 degrees. So this concludes today's lecture on phasors and impedances.